Hi, and welcome to the second segment in our Rotax Builder series, following the build of a Zenith CH750, powered by a Rotax 912IS fuel-injected engine. In this segment, we'll have a look at the progress that Zenith Build Center SkyTek has made on the wings and fuel system. Then we'll discuss some of the reasons for SkyTek's design choices in building the 750 fuel system in order to meet the requirements of the 912IS fuel injection system. Here we see the fuel tanks have been placed in the wings. A 1/2-inch diameter fuel vent line has been run to the outboard front side of each tank, next to the fuel filler neck. This vent line runs through the trailing edge of the wing to the root. A 1/2-inch diameter fuel supply line has been run from the rear inboard side of each tank. This fuel supply line also runs through the trailing edge of the wing, so that both the supply and the vent lines are neatly accessible at the wing roots. The wings have now been skinned and installed onto the 750 fuselage. The fuel supply and fuel vent lines enter the fuselage behind the rear spar carrier. Here we can see that SkyTek has temporarily installed clear fuel lines for testing purposes. The fuel supply and vent lines are plumbed into a header tank. The fuel supply line is then fed to the fuel shutoff, gasolator, and fuel pumps. The fuel return line is fed from the engine back to the header tank. It should be noted that the header tank, which has been specifically designed for this application, is made in such a way that it maximizes the purging of air from the fuel system. A good header tank design will also allow for quick refilling from the main wing tanks. This is the reason that SkyTek has chosen 1/2-inch fuel supply and vent lines between the header and fuel tanks. The SkyTek 750 fuel system, with the large diameter fuel lines and header tank, is designed to meet Rotax's requirements of providing the engine with maximum fuel flow at all times. Even though the 912IS is extremely fuel efficient, to effectively purge any air from the fuel system and to allow rapid self-priming of the fuel pumps, Rotax has designed the injection system to return a high volume of fuel to the aircraft tanks or header system. Special consideration has to be given to the airframe fuel system design to accommodate this and assure proper fuel flow in all possible flight conditions. Consider the design of a basic wing tank fuel system. In level flight, both wing tanks are able to supply fuel to the engine. However, in a side slip or an uncoordinated turn, there's a high possibility that one tank will have the fuel supply pickup unported or open to air instead of fuel, as the fuel sloshes to one side of the tanks. Combining a side slip or uncoordinated turn with low fuel levels in the tanks may result in both fuel supply lines becoming unported. An interruption in fuel delivery or ingestion of air into the fuel supply must be avoided for any fuel injection system. Any interruption in the high-volume fuel supply may cause a fuel-injected engine to stop. The high-volume fuel return requirements of a fuel-injected system also add potential complications to the fuel system design. In this example diagram of the SkyTek designed fuel system, we see that the fuel is allowed to very quickly flow from the wing tanks to the header tank through the 1/2-inch supply lines. By virtue of the large 1/2-inch diameter lines, any fuel vapor or air bubbles are simultaneously allowed to travel back up these lines unrestricted and then vented to atmosphere through the vented fuel tank lids. The fuel is then fed from the header tank to the filter and fuel pumps through 3/8-inch lines. The fuel return from the injection system is then fed back to the header tank through 3/8-inch lines. Any air in the system is vented from the header tanks to the wing tanks through the 1/2-inch vent lines. In an extreme condition of prolonged slip or uncoordinated turn, both fuel tank supply lines may become unported. In this case, fuel will cease to be supplied to the header tank until a level flight condition is returned to. SkyTek has designed the header tank to hold enough fuel for the high volume demands of full engine power for 5 minutes with an additional 1.5 safety margin. The header tank also incorporates a low fuel warning sender. This will warn the pilot of low header tank volume during a side slip, uncoordinated turn, or just a low fuel condition. It seems that SkyTek has thoroughly considered all potential issues in providing appropriate fuel supply to a fuel-injected engine in a high-wing aircraft. In the next segment of the SkyTek CH750 Builder Series, we'll see the results of this fuel system testing. If you have any comments on our Builder Series videos, email us at rotaxbuilderseries@rotax-owner.com.